So good morning students. So today we'll be discussing the questions of JEE Advanced 2025. So that happened on 18th of May. So we are discussing first paper 1 of chemistry right now. So let us start. So first paper, the section 1 was having single choice question. So single choice question with +3 -1 marking. So let us start with the first question. The heating of ammonium nitrate. So ammonium nitrate, NH4, NO2, ammonium nitrate heating at 60 to 70 degrees Celsius. So what will this give? Nitrogen plus H2O will be formed. And ammonium nitrite. So ammonium nitrite on heating at 200 to 250 degrees Celsius will give N2O, that is laughing gas, plus H2O will be formed. So this is a direct question from NCERT. So the question is saying heating of ammonium nitrite at 60 to 70 degrees Celsius will give me X. So the heating of ammonium nitrite at 60 to 70 degrees and ammonium nitrate at 200 to 250 degrees Celsius is associated with formation of nitrogen containing compound X and Y respectively. So X and Y respectively are A option. So answer is A option. Next question. The correct order of wavelength maxima of absorption band in the ultraviolet visible region for the given complex. So basically we have to arrange the following in order of their wavelength for these complexes. So wavelength, or basically you can say the crystal field splitting energy. First of all, if you see over here, these are all octahedral complexes. So crystal field splitting energy will depend upon inversely proportional to wavelength of the absorption. So let us first arrange in the order of their crystal field splitting energy. So crystal field splitting energy will depend upon the strength of the ligand. So strength of ligand. So let us first arrange the following ligands in order of their strength. So cyanide Cn- will be the strongest ligand, then ammonia, then H2O, and then chloride. So chloride is the weakest ligand among the following. So chloride, as you know, is a weak field ligand. Now this is the order of their strength of the ligand, and this will be the order of their crystal field splitting energy. So if I arrange the following complex in order of their crystal field splitting energy, so that will be, so CO, Cn6. This complex will have maximum crystal field splitting energy, then ammonia +3, then one of the ammonia is replaced by H2O over here in this ligand, and at the last option is CONH3 5Cl. So these are the complexes given. So if we arrange the following in order of the crystal field splitting energy, so because cyanide is a strong field ligand, so over here crystal field splitting energy will be more. So this is the order of the crystal field splitting energy. Now we have to arrange in order of their wavelength. So order of the wavelength we have to arrange. So wavelength is inversely proportional to the crystal field splitting energy. So if this is the order of crystal field splitting energy, so order of wavelength will be reverse. So as you can see from the option, the order of wavelength will follow this order, that is A option. So answer will be A option. Next question. One of the products formed from the reaction of permanganate ion with iodide ion in neutral aqueous medium. So permanganate ion is MnO4- with iodide ion in neutral medium. So this is the question directly from NCERT. In NCERT also this reaction is given. So in neutral medium, the manganese will go from +7 to +4. So MnO2 will be formed, +7 to +4 will be formed, and iodide ion will be oxidized to IO3-. So in neutral medium or slightly alkaline medium, this is the reaction given directly in NCERT. So iodide ion will go to IO3 minus. So answer will be B option. Next question. Consider the depicted hydrogen in the hydrocarbons given below the most acidic hydrogen. So acidic hydrogen, for that you have to look for the stability of conjugate base. So more is the stability of conjugate base, that hydrogen will be removed easily and that hydrogen will be the most acidic hydrogen. So let us remove the hydrogen and form the conjugate base. So this is the conjugate base for A option, for B option, then for D option and for C option. So these are the conjugate base form. So all the negative charge of the conjugate base is in conjugated system. Then, but if you see in the B option, when you make the resonating structure in the B option, when you are making the resonating structure of this conjugate base, so when the negative charge is in conjugation, so when the negative charge is dispersed by conjugation, or when the resonance will take place in this, negative charge will come over here. So in this, negative charge will come over here. In this, when double bond is formed, negative charge will be formed over here. You can make the resonating structures in all the options. In the B option, when the negative charge is coming over here, this is becoming aromatic, which is not the case with any other option. So if you see over here, even if the negative charge is coming over here, this is not becoming aromatic. So this was the negative charge, and when the double conjugation resonance will take place, so negative charge will come over here, this will not become aromatic. So it is becoming aromatic only in the B option. So because of aromaticity, this will be the most stable conjugate base. So this will form the most stable conjugate base. Because of this hydrogen is the most acidic hydrogen. So answer will be B option. Next question. So let us come to the section 2. Section 2 of paper 1 was made up of multiple choice question, more than one option correct. Partial marking was there, -2 was the negative, +4 if you are opting all the options correct. Partial marking for +1, +2, +3 accordingly. So let us start with the question. So question number 5, that is multiple choice. Regarding the molecular orbital energy levels of homonuclear diatomic molecules. So it is regarding the which of the following statements are incorrect. So basically you have to tell which of the following are incorrect statement regarding the molecular orbital energy levels based on the molecular orbital theory for homonuclear diatomic molecules. So first option is saying bond order of Ne2 is 0. Obviously, no, neon is a noble gas. If you calculate the bond order according to molecular orbital theory by writing its electronic configuration, that is neon Ne2, you will take 18 electrons, sigma 1s2, sigma star 1s2. You can write down the electronic configuration and find out the bond order. Bond order will come out to be 0. So answer A option is correct. You have to tell incorrect. So you have to tell incorrect. So A option is correct. That will be not there in the answer. Now B option is saying the highest occupied molecular orbital of F2. F2, so neon you will take 20 electrons, write down the electronic configuration, bond order will come out to be 0. So this is correct. This will not be taken in the answer. We have to tell the incorrect one. Then for F2, it will be 18 electrons. So let us write down the electronic configuration of F2, that is 18 electrons according to molecular orbital theory. So sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, then sigma 2pz 2, then pi 2px, pi 2py, then pi star 2px, pi star 2py. So total 18 electrons, 2, 4, 6, 8, 10, 12, 14, 16 and 18 electrons. So this is the electronic configuration of F2. Now highest occupied molecular orbital HOMO, that is highest occupied molecular orbital over here will be pi star. So pi star is the HOMO for F2. It is not sigma type. So this one is incorrect. So you have to tell which one is incorrect. So B will be the answer. Multiple choice question. Let us see the next option, C option. Bond energy of O2 plus is smaller than bond energy of O2. So for O2 plus and O2, you can compare bond energy is directly proportional to bond order. So let us find out bond order for O2. O2 is having 16 electrons, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz, pi 2px, pi 2py, 2, 4, 6, 8, 10, 12, 14, and pi star 2px, pi star 2py, 1 each. So bond order for O2 will come out to be, according to molecular orbital theory, bond order will come out to be 2 for O2 molecule. Now let us find out bond order for O2 plus. O2 plus will have 15 electrons. So it will have pi star 2px 1 and pi star 2py 0. So over here 1 electron will be less in anti-bonding. So bond order over here will come out to be 2.5. So bond order in case of O2 is 2, O2 plus is 2.5. So bond energy is directly proportional to bond order. So bond energy will be greater for O2 plus as compared to O2. Right? So C option is saying bond energy of O2 plus is smaller than that of O2. That is incorrect. So you have to tell which one is incorrect. So C will be also the answer. So B and C are answer. A is not the answer. Let us check the last option also. D option. Bond length of lithium plus 2 is larger than bond length of boron plus 2. So lithium plus 2. So there will be 6 electrons. You will find out the bond order. Bond order will come out to be 1. And boron 2, that is 10 electrons. That will also have bond order 1. So for both the cases, the bond order is same. So for lithium plus 2 and boron, bond order is same. That is coming out to be 1. So you cannot use this bond length is inversely proportional to bond order because bond order is same for both of them. Now, based on the size of the atom, you can decide the bond length. So lithium plus 2, the bond is between 2 lithium atoms, and boron plus 2, the bond is between 2 boron atoms. So lithium, beryllium, boron. Along the period, effective nuclear charge increases and atomic size, atomic radius decreases. So boron is slightly smaller than lithium. Lithium is slightly bigger than boron. So the bond length of lithium will be slightly bigger than that of boron. So based on the size of the atom, bond length of lithium plus 2 is larger than that of boron. So this is correct statement. So this will be not included in the answer, because you have to tell only the incorrect one. So the incorrect ones are B and C in this question. So for question number 5, answer will be B and C. Next question. The pair of diamagnetic ions. So lanthanum is a D block element. So 6s2, 5d1, this is lanthanum. Now lanthanum plus 3 will be 6s0, 5d0. So it is diamagnetic, no unpaired electron, 4f0. Then cerium. Cerium is the next element, that is 6s2, 5d1, 4f1. So this is the electronic configuration of cerium. So over here, cerium plus 4, all the 4 electrons will be removed. So it is also diamagnetic ion. So A option is correct. So there, that is diamagnetic. Let us check the other options also. So ytterbium atomic number 70. So this is 6s2, then 4f14. So ytterbium plus 2, the 2 electrons will be removed from the outermost 6s. So this is also diamagnetic, no unpaired electron. Lutetium. Lutetium is 71, that is 6s2, 5d1, 4f14. So over here, when lutetium plus 3, the 3 electrons are removed from the outermost 6s and 5d, so that will be also diamagnetic. So these two are also diamagnetic. So B option is also correct. When you can eliminate the other option. If lanthanum plus 3 is diamagnetic, then lanthanum plus 2 will not be diamagnetic. So what will be lanthanum plus 2? So this will be 6s2, 6s0 and 5d1. So 5d1, one unpaired electron will be there. Lanthanum plus 2 will not be diamagnetic. Right? So this is cerium plus 4. Now cerium plus 3. So cerium plus 3 will be 6s0, 5d0 and 4f1. The 3 outermost electron will be removed. So it will still have one unpaired electron. So this will also be not diamagnetic. Then similarly ytterbium. So this is ytterbium plus 2. Now ytterbium plus 3 will be 4f13. 4f13 there will be one unpaired electron. So it will not be diamagnetic. Lutetium plus 2. Lutetium. So this is lutetium plus 3. Now lutetium plus 2 will be 6s0, 5d1, 4f14. So it will have one unpaired electron. So it will also be not diamagnetic. So answer will be A and B option for this question. So question number 6, answer is A and B. Next question. For the reaction sequence given below, the correct statement are, so this is the reaction sequence HBr. HBr will give me addition of HBr will give me bromine. Bromine will be added according to Markovnikov addition rule. So this is symmetrical, no need of any confusion. Filkenstein reaction. So Filkenstein reaction is basically used for preparation of iodides. So basically iodide ion with acetone. So acetone is used as a solvent over here. So in this, the iodide, bromine will be replaced by iodide. So in Swartz reaction, basically ionic salts of fluoride are used for preparation of fluoride. So over here R is having fluoride, Q is having iodide and P is having bromide ion. So in the option X is any atom other than carbon and hydrogen, and it is different in PQR. So X is basically the halogen that is different in PQR. P is bromine, Q is iodine and R is fluorine. Now CX bond length in P. So basically CX means carbon, bromine bond length, fluorine, carbon, bromine and carbon iodine. So this is the order of CX bond length. So CX bond length in PQR will follow the order. So this is CF is R, then CBR is P and this is Q. So follows the order Q, R, P. No, this is wrong. So it is QPR. So CX bond length, carbon iodine bond length is maximum. So A option is incorrect. You have to tell the correct statements. Then CX bond enthalpy. So bond energy is inversely proportional to bond length. So bond energy is inversely proportional to bond length. So this is the order of their bond length. So what will be the order of their bond energy? That is inversely proportional to bond length. So order of bond energy will be opposite. R greater than P greater than Q. So R greater than P greater than Q. So bond enthalpy or bond energy order is correct. So B is the answer. B will be one of the answer. Multiple choice question. Let us see the next option. Relative reactivity towards SN2 reaction in PQR. So SN2 substitution, the reactivity will follow the nucleophilic substitution will follow the rate will follow the order of leaving group. So better leaving group, the rate will be more. So iodide is a better leaving group, then bromide, then chloride. So the rate SN2 will be more in Q, then in P, then in R. So QPR will be the order. So this is also not correct. So C option is also not correct. For SN2, the rate will follow the ability of the leaving group. Better is the leaving group, more will be the rate for SN2. Now pKa value of the conjugate acid of the leaving group. So leaving group in PQR. So what are the leaving group in PQR? Fluoride, bromide and iodide. So these are the leaving group. Now conjugate acid. So conjugate acid will be HF, HBr, HI. The pK value we have to tell. So order of pK value. So first of all, let us arrange the following in order of Ka value, that is directly proportional to their acidic strength. So Hi is a stronger acid than HBr, which is a stronger acid than HF. So pK value is inversely proportional to the value of Ka. So the order for pK value will be opposite, HBr less than HF. Now this order will be in terms of PQR I am writing. So Hi is coming from Q, so Q less than HBr is coming from P, which is less than HF coming from R. So this will be the order of their pK value, R greater than P greater than Q. So RQP, this is also wrong. So only B option is correct. So though it is a multiple choice question, but only one option is correct, that is B option. Next question. In the electrochemical cell, the dichromate ions in aqueous medium. So dichromate is Cr2O72-. Dichromate ions in aqueous acidic medium are reduced to chromium +3. The current in amperes that flows through the cell for time, that is given 48.25 minutes, to produce 1 mole of chlorine. So chromium over here is going from +6 to +3. So to produce 1 mole of chromium ion, chromium +3, we need 3 moles of electron. So number of moles of electron required is 3. And 1 Faraday is also given. So charge required is 3 Faraday. That is 3 into 96500 coulomb. And that will be equal to current into time. Current we have to find out in amperes and time will be in seconds. So time is given in minutes, 48.25 minutes, converting this into seconds. So from here you will get the current in amperes, 3 into 96500 by 48.25 into 60. 10 will get 3 2s are. So 9650 by 48.25, 96.5. So exactly 100. So current is coming out to be 100 amperes. So answer will be, it is a numerical type question. You have to answer up to 2 decimal places. So answer will be 100.00 plus. So this will be the answer. Next question. At 25 degrees Celsius, the concentration of H plus ion is given out to be, so the concentration of H plus ion in 10 to the power aqueous solution of weak monobasic acid. So let the weak monobasic acid be HA. The concentration of this acid is 10 to the power -3 molar. The concentration of H plus ion we have to find out. Having dissociation constant, so dissociation constant of the acid is 4 into 10 to the power -11. And the concentration is in terms of this, we have to find out the value of X. So concentration is X into 10 to the power -7 molar. We have to find out the value of X. Now over here, since it is a weak acid, dissociating very sparingly. So let us, we can directly use the formula over here. So concentration of H plus ion for weak acid is under root Ka into C, where K is the dissociation constant of the weak acid and the initial concentration is 10 to the power -3. So from here you will get the concentration of H plus ion to be 2 into 10 to the power -7 molar. Now if you have marked or given the answer 2, you are wrong. If you have marked the answer 2, the value of X is 2, you are wrong. Why you are wrong? Because the H plus ion coming from this weak acid is comparable to the H plus ion coming from the water. So H plus ion coming from the water is of the order of 10 to the power -7 molar. So the value is comparable. So you cannot neglect the H plus ion coming from water. So over here you have to consider the H plus ion coming from water. So this is the mistake most of the students must have done. So you cannot neglect the H plus ion coming from the water. Like suppose you are having 10 to the power -7 molar HCl. So you cannot neglect the H plus ion coming from the water. Even for 10 to the power -6 molar HCl, you cannot neglect. And suppose it is 10 to the power -8 molar HCl. Then the H plus ion coming from the water is in fact more than from the HCl. So over here you must have done these type of questions in which you cannot neglect the H plus ion coming from the water. So how to solve these type of questions? You know, You can consider it to be mixture of two weak acids. One is the weak acid HA and one is water. Water is also a weak acid. So over here, when you are considering the mixture of two weak acids, the concentration of H plus ion for mixture of two weak acids is given by C1Ka1 plus C2Ka2. Now in case of water, this will be nothing but Kw. So Ka1 into C1 plus ionic product of water. So this is the formula for finding out concentration of a weak acid in water, where the H plus ion coming from the weak acid is comparable to the H plus ion coming from the water. So this part is nothing but Kw. This, I think you must have done the derivation of this formula. So we'll be directly using this formula over here to calculate the H plus ion. So Ka value that is given in the question is 4 into 10 to the power minus 11. And C initial concentration is 10 to the power minus 3 and ionic product is 10 to the power minus 14. So 4 plus 1, 5 into 10 to the power minus 14. So this will be root 5 is 2.236 into 10 to the power minus 7. So this will be the exact answer. Now you can round off because you have to report to two decimal places. So 2.24 you can round off. This will be the value of X. So the answer over here will be 2.24 up to two decimal places. Those who have marked or written answer 2 will be getting negative marks. Although this section was not negative, but you will not get positive marks for this. So this section, there was plus 4 and 0 marking. Come to the next question. The molar volume of van der Waals gas can be calculated by expressing the van der Waals equation as a cubic with Vm as variable. So let us write down the van der Waals equation in terms of molar volume. P plus A Vm square, Vm minus B is equal to RT. This is the real gas equation, van der Waals equation in terms of molar volume. Now it is saying cubic. So let us expand this. PVm plus A by Vm minus BP minus AB by Vm square is equal to RT. Now let us further solve this. So multiplying by Vm square, so PVm cube, it will be cubic as given in the question, plus AVm minus BP Vm square minus AB is equal to RT Vm square. So from here PVm cube plus Vm square term I am taking first minus BP minus RT. So BP plus RT whole in bracket Vm square plus AVm minus AB is equal to 0. So this is the cubic equation that the question is talking about. Molar volume of van der Waals gas can be calculated by expressing the van der Waals equation as a cubic with Vm as the variable. The ratio in moles per decimeter cube, that is moles per liter, of the coefficient of Vm square. So what is the coefficient of Vm square? That is P. So coefficient of Vm square. So coefficient of Vm square is minus BP by RT. So coefficient of Vm square is minus BP by RT. And the coefficient of Vm. So coefficient of Vm is A. So this ratio you have to find out. Minus BP plus RT by A. The ratio of coefficient of Vm square to the coefficient of Vm for the gas having van der Waals constant, if the value of A is given in a decimeter only, so no need to change, and the pressure is also given in atmosphere. The van der Waals constant AR in terms of decimeter raised to power 6, that is liter square, atmosphere mole raised to power minus 2, and the value of B is also liter per mole. So that is required, and you have to find out the ratio in moles per liter only. So no need to change the units of any, just put the values. Pressure is also given in atmosphere, temperature is in Kelvin. So directly put the values, you will get the answer. So over here minus B. B is how much? 0.06. Pressure is 300 atmosphere. R value is given in the question as 0.082. Temperature is 300 Kelvin. by A value is also given, that is 0.6. So A value is given, that is 6. So solving this, further you can solve this. So that will be minus of 0.06 into 300 plus 0.082 into 300 by 6. So solving this, you will get minus of, this is 6 3s are 18 plus 8, 24.6. So 24.6 by 6. So this will come out to be 42.6 by 6 minus 7.1 will be the answer. So answer for this question up to 2 decimal places, what you have to report? Minus 7.10. So this will be the answer. Next question. Consider the ideal gas behavior expansion work done in kilojoules per mole when 144 grams of water. So number of moles of water will be 144 by 18, that is 8. When 144 grams of water is electrolyzed completely under a constant pressure. So work done in expansion. So work done in expansion will be negative, that is work done by the system. So P delta V, and the external pressure is constant under constant pressure. So work done will be minus P delta V, that can be written as delta NGRT at constant temperature. Temperature is given out to be 300 Kelvin. So water is electrolyzed. So what is water? Water in liquid state will be electrolyzed to hydrogen gas and oxygen gas. So let us balance this reaction. So now there are 8 moles of water. So 8 moles of water, when it will undergo electrolysis, that will give me 8 moles of hydrogen and 4 moles of oxygen. So delta Ng for this reaction will be number of moles of gaseous product minus gaseous reactant. So water is liquid state, so that will be not taken into account. So delta Ng for this reaction will be 12. So work done we have to find out minus delta Ng, that is 12. R value is 8.3 joules per Kelvin per mole and temperature is 300. This will give me the work done in joules. So work done, if you are finding in kilojoules, divide this by 1000. So this will be 12 into 8.3 into 300 by 1000. So this will give me the answer in kilojoules. So this will be 36 and 83. So this will be minus 298.8 by 10. That is minus 29.88 kilojoules. So this will be the answer. So answer for this question will be minus 29.88. Come to the next question. Monomer X involved in the synthesis of nylon 6,6. So what are the monomers of nylon 6,6? Hexamethylene diamine. So hexamethylene diamine is one of the monomer, and the second monomer of nylon 6,6 is adipic acid. So adipic acid, both are having 6 carbon atoms. That is why it is named nylon 6,6. So the monomers both are having 6 carbon atoms. So these are the 2 monomers of nylon 6,6, hexamethylene diamine and adipic acid. The monomer X involved in the synthesis of nylon 6,6 gives positive carbylamine test. So carbylamine test is given by primary amines. So that X will be this only. This will only give me the carbylamine test. So this is X. Now 10 moles of X. So 10 moles of X are analyzed during Dumas method. So Dumas method is used for the analysis of nitrogen in the organic compound. So in Dumas method, nitrogen will be escaped in the form of nitrogen gas. Question is asking the amount of nitrogen gas evolved is. So if there are 10 moles of this, so you can directly apply POAC, principle of conservation of atom. So 10 moles of this is having 2 20 moles of nitrogen atom and 10 moles of nitrogen gas will be released. So by POAC, 10 moles of nitrogen gas will be released. So amount of nitrogen gas will be number of moles into molecular weight of nitrogen gas. So amount will be 280 grams. So amount in grams will be 280. So numerical type question, the answer you should be reporting is plus 280.00. So this is the answer. Next question. The reaction sequence given below is carried out by 16 moles of X. So there are 16 moles of X. The yield of the major product in each step is given below in the parenthesis. The amount in grams of S you have to find out. Now sodium triether. So this is Fittig reaction. Woods only Fittig reaction because bromine is directly attached to the benzene. So it will be not called Woods reaction, Fittig reaction. So Fittig reaction and after hydrolysis. So what will this hydrolysis do? It will hydrolyze this group to aldehyde. So first of all, in Fittig reaction, the two benzene ring will be attached together, and there will be this on hydrolysis will give me aldehyde. So there will be two aldehyde groups. So this is P. So this will be P. You can check the molar mass of P will come out to be 210. Now 100% yield, that means number of moles of P is also 16. Now this on NaOH. So NaOH, it will undergo no alpha hydrogen is there. Canizaro, what type of Canizaro will be there? Intramolecular Canizaro. So this will undergo intramolecular Canizaro. So aldehyde with no alpha hydrogen will undergo Canizaro, and because there are two aldehyde groups in the same molecule, it will undergo intramolecular Canizaro. So in intramolecular Canizaro, one of this aldehyde group will be oxidized to carboxylic acid and another will be reduced to alcohol. So after hydrolysis you will get the carboxylic acid. Before hydrolysis, you will get the salt of carboxylic acid. Now over here the yield is 50%. So over here 16 molecules will give me 8 molecules of Q. So this is Q and we are getting 8 molecules of Q. 8 moles, sorry. 8 moles of Q. Now Q NaOH CO. So decarboxylation of this will take place. So what will be R? So after decarboxylation, so I am making this, removing this COH group. So now this will be R. So after decarboxylation, this is R. So this is R. Again, the yield is 50%. So number of moles of R will be 4. Now PBr3. PBr3 over here. PBr3, what will this, sorry, this is alcohol. This is alcohol. Alcohol and carboxylic acid of the Q will be removed. So decarboxylation will take place and this is alcohol, CH2OH. So this is the structure of R. Now over here PBr3, what will this PBr3 do? It will remove or convert the alcohol into alkyl halide. So over here bromide will be formed. So this is Q. So sorry, this is the structure of T. So this will be T. So this is T formed. So again the yield is 50%. So 2 moles of T will be there. Now there is 2 moles of over here 8 moles of Q. Then over here 4 moles of R. Then over here 2 moles of T will be there. Now these 2 moles of T are reacting with R. So R is also there. So what was R? This was R. CH2OH, R will be there. So this is alkyl halide and this is alcohol. So T is basically, this is alkyl halide and alcohol. This will undergo Williamson ether synthesis. So in Williamson ether synthesis, this will undergo this hydride. Sodium hydride is used as a base to form the alkoxide ion and it will undergo SN2 reaction with this. Since benzene is a planar molecule, steric hindrance will not be there. So don't worry about the steric hindrance. But if you are directly substituting this hydride with alkyl halide or substituting the hydrogen over here, this is not possible because the hydride will never attack this carbon atom directly and this will not replace the halogen. So over here, this hydride is basically used as a base in Williamson ether synthesis. So in Williamson ether synthesis, you must have studied sodium hydride is also used as a base to form the alkoxide ion. Now this alkoxide ion will undergo substitution, and with this, so after substitution, what will be the product? So this alkoxide ion will be formed that will attack, and the product will be CH2. So this will be the product, that is S. So this is S. So this is the S. Now if I am having 2 moles, if T is, now the yield of this reaction is also 50%. So over here 1 mole of S will be formed. So we are starting with X, that was 16 moles, and with this we are getting 100% yield. That means now over here, when 16 moles of X are reacting, basically in Fittig reaction, now 8 moles, even if the yield is at 100%, 8 moles of this will be formed. So 8 moles of this will be formed. So 8 moles of this will be formed. Now if the yield is 50%, then 4 moles of this will be formed, because 2 moles of this will combine to give 1 mole of P. So even if the yield is 100%, 16 moles of this will give me 8 moles of P. Now over here yield is 50%, 4 moles of Q will be formed. Again 50%, 2 moles of R will be formed. Again 50%, 1 mole of T will be formed. So 1 mole of T is getting formed. Now this is reacting with the R will be remaining some 1 mole. It is reacting with R, Williamson ether synthesis. Again the yield is 50%. So basically half mole of S will be formed. So over here the number of moles formed of S is half, and the amount in grams of S you have to tell. So amount in grams of S will be number of moles into molecular weight. So molecular weight of S will come out to be 350. So your answer will be 175. So up to 2 decimal places plus 175.00. So this will be the answer. The section 4 of paper 1 was consisting of 3 questions, match the following type. +4 -1 was the marking scheme. The questions were easy only because the options were not tricky. So passing H2S in presence of ammonium hydroxide. So passing H2S in presence of dilute HCl, that is for group 2. So this is for group 2, that is copper. You can directly see over here. Now ammonium hydroxide in ammonium chloride, that is for group 3. Group 3, that is aluminium. So you can see S is corresponding to 1, then R is corresponding to 2. These 2 options are clear. Now ammonium carbonate in presence of ammonium hydroxide, that is basically for group 5. This is for group 5, that is barium. So barium carbonate white precipitate is formed. So Q is corresponding to 4, and H2S in presence of ammonium hydroxide, that is for group 4, that is manganese. So group 4, that is manganese. So P is corresponding to 3. So P is corresponding to 3, Q to R, R Q to 4, R to 2, and S to 1. So answer will be A option. Next question. The major products obtained in the list 2. So the major product of the list 2 are the reactants for the name reaction, that in the list 1. Match the list 2 with the appropriate. So toluene chromyl chloride carbon disulfide. So toluene chromyl chloride will undergo oxidation. This is known as Attard's reaction. This is Attard's reaction. Aldehyde will be formed. Now this aldehyde is the Reactant for the name reaction in list 1. So reactant for the name reaction in list 1. Aldehyde can be, this benzaldehyde can be used for Cannizzaro reaction. There is no alpha hydrogen. So S is corresponding to 1. So S is corresponding to 1. Then second is benzoic acid. Benzoic acid PCl5. That will give me acid chloride. Then with ammonia, amide will be formed. Now P4O10 is a strong dehydrating agent. Heating, cyanide will be formed. So this cyanide is basically used in Stephenson reaction. So cyanides are used in Stephenson reaction. So cyanides are the reactants of Stephenson reaction. So what is Stephenson reaction? In Stephenson reaction, cyanides in presence of SnCl2, HCl are converted into aldehydes. So this is Stephenson reaction, SnCl2, HCl, and then H2O is also heating. So this is Stephenson reaction. So cyanides are the reactants of Stephenson reaction. So P is corresponding to 2. Cyanides are formed in second case. Then third is nitrobenzene. Nitrobenzene on reduction will give me reduction with iron HCl, will give me aniline. Then aniline with HCl NaNO2 at 0 to 5 degrees Celsius. That will give me disonium salt. Benzene disonium chloride will be formed in this case. So which is an intermediate in St-Meyer's reaction. So in St-Meyer's reaction, benzene disonium chloride is reacted with copper salts like CuCl, CuBr, CuI, CuC and copper plus 1 salt to convert into respective compounds. So the reactant of St-Meyer reaction is benzene disonium chloride. So Q is corresponding to 3. In third case, benzene disonium chloride will be formed. And Hofmann bromamide degradation, basically the reactant is amides. So over here, let us check for the fourth and fifth option. Toluene. So toluene with chlorination, then Tollens reagent will give me carboxylic acid. And toluene will first form aldehyde that will be oxidized to carboxylic acid by Tollens reagent. Then acid chloride will be formed with SOCl2, and with ammonia, amide will be formed. So this amide is the amide formed over here is the reactant for Hofmann bromamide degradation, in which the amides are converted into, with bromine in presence of NaOH, are converting into primary amines. So R is corresponding to 4. So answer will be P corresponding to 2, Q corresponding to 3, R corresponding to 4, and S corresponding to 1. So S corresponding to 1. So from the options you can see P is corresponding to 2, 3, 4, 1. 2, 3, 4, 1. That is option B will be the answer. Last question. Match the compounds in list 1 with the appropriate observation in list 2 and choose the correct options. Reaction with phenyl disonium salt gives yellow dye. So this yellow dye is nothing but an azo dye. So what are azo dyes which are having this azo group are called azo dyes. So yellow dye is an azo dye that will be formed by disonium chloride with phenyl disonium salt. So clearly R is corresponding to 1. So that will give me the azo dye. Now in reaction with ninhydrin. So ninhydrin test is used to detect nitrogen, that is amines, primary and secondary amines, with and amino acids also are detected by ninhydrin test. So basically it can be primary, secondary amine, ammonia, or amino acids, nitrogen containing compounds. That gives purple color with ninhydrin test. And FeCl3 violet color, that means phenol group is also there. So with violet color, phenol group should be also there. So phenol group is there. So phenol group is there only in the P option, and amine is also there only in the P option. So clearly P is corresponding to 2. Reaction with glucose will give corresponding hydrogens. So what are hydrogens? So hydrogens are formed. So hydrogens will be formed by this option. This option can only give hydrogens. So S is corresponding to 3 option. So S is corresponding to 3. So R is corresponding to 1. P is corresponding to 2. S is corresponding to 3. So P is corresponding to 2. R is corresponding to 1. S is corresponding to 3. And then no need to check for the last option, but still we'll check. Q. Q is this compound. Now the remaining options are Lascine's extract of the compound treated. Lascine extract is basically used for detection of sulfur, nitrogen and halogens in the compound. Now Lascine extract will be the ionic form of this. So it can be NaCN, Na2S, NaX ionic form. When treated with dilute HCl followed by addition with FeCl3 gives blood red coloration. So blood red coloration is conformation for thiocyanate ion. So that means thiocyanate ion is there. That means both sulfur and nitrogen. So in this compound both sulfur and nitrogen are present. Then only thiocyanate ion will be formed in the Lascine extract test. So sulfur is not present in any of the compound, as you can see. So this option is not matching with anyone. So the last option, let us see the 5th option, that will be matching with Q. After complete hydrolysis. So if we are doing hydrolysis of Q, this will undergo hydrolysis, and this group will undergo hydrolysis. This group will also undergo hydrolysis. So after complete hydrolysis, it will give ninhydrin test. So ninhydrin test is given by primary amines. So this group will give me amines on hydrolysis. Amides will give me amines on hydrolysis. So this part will be giving me the amine, that is, and this part will be giving me the carboxylic acid. So primary amine will be there. So that will give the ninhydrin test. So Q will give the ninhydrin test, and it does not give positive phthalene dye test. Phthalene dye test is basically used for detection of phenol group. So phenol will be converting into phenolphthalein, which is also used as an indicator. So phthalene dye test is for phenol group. So phenol group is not present in this compound. So this will not give the phthalene dye test also. So confirmatory, we can check that Q is corresponding to 5. So no need to check this much in the exam. Save your time. You can directly mark B option. Answer will be B option. So also watch the video for the second lecture. So thank you.